Assalamu alaikum. I am Mr. Nader Ismail and this is our channel for physics teaching. Today we are going to discuss the difference between the shunt resistor and multiplier resistor. And let's start. The first point of comparison is what are the properties of each. Shunt resistor, it is a small resistor that is connected in parallel to the coil of the galvanometer to convert it into an ammeter, that can measure high current value. On the other hand, multiplier resistor, it is a large resistor that is connected in series to the coil of the galvanometer to convert it into a voltmeter that can measure high voltage value. And as we can see, the properties are reversed. They are opposite in their properties, which can be considered as a definition for each. Okay. And let's move on to the drawing of each in the connection. LRS, as you can see, makes a division, so it is a current divider for LRG. On the other hand, the multiplier is a voltage divider, and we have to know that we measure the summation of current here and the voltage there, and that's why we say that the modification increases the measurement of the range of measurement as it measures the summation. Let's move on to the connection of the device itself in the circuit. The device itself has reversed connection to its modification. I mean, if the modification is parallel, so the device in the circuit is series. The other way around, when the modification is series, its device is parallel. Okay. And here we have the rule of each. RS at a side, it is equal IGRG divided by the bracket I minus IG. And here we can notice that RS and I inversely proportional, while IGRG constant here. On the other hand, RM at a side, V minus VG divided by IG. And the relation here, RM is directly to voltage, while VG and IG is constant. So let's move on to the relation of sensitivity. Sensitivity of a device, it is the division between the measurement before modification and after. So here is sensitivity of ammeter IG divided by I, while sensitivity of voltmeter VG divided by V. Okay, let's move on to the advantages of each, and here the advantages of each are common. Both have same advantages to make measurement. I mean, here both protect LRG from damage and allow it to measure high measurement through the deflection of its pointer. Here LRS is much less than LRG, and that's why it withdraws most of the circuit current, and this is an advantage because this protects LRG and allow it to measure higher current value. On the other hand, LRM makes the same thing but with opposite connection, because a voltmeter as a resistance, it is much more than the resistance of the circuit itself. So it allows most of the current to pass through the circuit, while the voltmeter, due to the presence of Rm, withdraw a less current value. Okay, understood this point. Okay, let's move on to the second advantage of both, that they both keeps the R total of the circuit constant. I mean, and if a device is a resistance now, it has to keep the circuit without a change, and that's why we know that R ammeter is nearly equal 0. This is because the shunt resistor is very small value, and in parallel connection the equivalent must be less, and that's why we can neglect the resistance of the ammeter in the circuit. On the other hand, the property that LR voltmeter is very large, it makes LR equivalent after contact nearly equal R circuit, and that's why we connect both at the same time to keep R total constant. Both increases the measurement and decreases the response of the pointer or the sensitivity at the same time. As we can see, RS decreases, measurement increases, sensitivity decreases, and RM makes the same thing, but in opposite way. When RM increases due to being large, LV increases, and when LV increases, sensitivity decreases. That's all for now. Thanks for watching. Hopefully you will like it, sharing our video. Bye bye.